Okay, welcome back to part 2 of the video. Now we're going to start exploring graphs of exponential functions. So there's two things that you need to be aware of on graphs. One is a new vocabulary word called asymptote. So if you're looking at this first graph here, notice that it either is going up, but it never crosses that x-axis, or if we had a negative starting amount, it'll be going down here, but it never ever touches or crosses the x-axis. That's the boundary. The boundary is our asymptote. In Algebra 1, we're working with very basic exponential functions, and so our asymptote is always going to be at our x-axis, our y equals 0. In Algebra 2 and beyond, we start moving the asymptotes around. But in Algebra 1, our asymptote is always going to be y equals 0, which is our x-axis. Now, the other thing that you really need to see, besides our a value being our y-intercept and our asymptote, is our parent function of an exponential one is going up is when our factor is greater than 1. So what we have is a growth that's going up as long as our a value is positive and our factor is greater than 1. We also have, if our factor is less than 1 and our a value is still positive, we're going to have what we call decay. We'll explore this more next class. But decay means it's going down. It's still never going to touch or cross the x-axis, but it's going down because our factor is a fraction. We won't look too much at the reflection, but when our a value is negative on either one of these two graphs, if we have an a value that is negative, it's going to reflect across our x-axis. It's going to reflect the graph down. We have the same thing in quadratics. We'll look at that as well, reflections of lines. So that's the things to remember, especially the word asymptote. And our initial amount, the a value, is always our y-intercept. So let's look at number 11. We're going to work through together, and then number 12 I'm going to ask you to do on your own. So number 11, it says we want to graph and identify all the parts on it. Easiest way to do these is to put it into the y equals of your calculator and pull up the table. So I'm going to go ahead and just draw my axis kind of down. I'm going to give myself just a little bit of room in the other quadrants, but mostly just have a first quadrant graph. Okay, so my y-intercept. If I look at my equation, my y-intercept is always my initial amount. So my y-intercept is going to be 0, 2. That's a 0. So I can go ahead and graph my y-intercept right here on the 2. The asymptote. Just told you, the asymptote is always y equals 0 in Algebra 1. That means that this graph is never going to cross this boundary. So we know right there that everything is going to be above the x-axis. So if we put this into the table, you're going to have, when x is 0, your starting amount is 2. If our exponent was 1, so if we look at our x here, and this was a 1, 1/4 times 1 is 1/4. So it's really just 2 times 1/4, which is 1/2. So our next point is 1, 1/2, which is about right here. So we can see that it's going down. If we went the opposite direction and had a -1 as our exponent, that would end up making our number 8. So now I can really see my graph. I'm going to go ahead and graph it. It's going down, but it's never crossing the asymptote. And it looks like I missed my point. Let's see if I can draw that again this time. Getting my half in. Okay, so there's my exponential function. My domain. If I look and try and put a left boundary here, it's going to continue going up and over. So I can't put a left boundary and I can't put a right boundary. So my domain is all real numbers. And when I look at my range is read bottom to top. Well, I definitely have a bottom boundary. By definition, my asymptote is my boundary. So I know that this thing will never ever touch my asymptote. So it's never going to touch 0, but it's everything greater than 0. So my range is y is greater than 0. It's not equal to because it's never going to touch it. Now I want you to do number 12 on your own, identifying all the parts, and then check back for the explanation. Okay, number 12 was very straightforward, especially if you used your calculator in the table. Just the big thing to remember is we've got a negative 2 raised to the x power. Our a is the negative 1 because our factor cannot be a negative number, so our b is positive 2, our factor. The negative in the a value is what reflected this down. Okay, number 13. Number 13 is it's a neat one. It's a bacterial growth, which is very classic exponential. So what I want you to do is to start by making a little table of the points on your paper so that you can see what the factor is, what it's multiplying by every time, and you can see your starting amount, and then answer all the questions and check back for the explanation. Okay, number 13 is very straightforward, just as long as you broke it down into all the different pieces of the puzzle, started somewhere, and found out all your information. Biggest thing to remember is our domain, because this is a situation, isn't all real numbers like it is in just a straight equation problem. You can't have negative days. And so the domain and the range are both at a limiting from the situation. Okay, on number 14, I want you to use the process of stat edit using your graphing calculator to find the function that fits this data. So you would just go back through the process of putting it in stat and edit, but this is not linear data. This is exponential data. So instead of doing stat calc 4, which is a linear regression, you're going to do stat calc 0, which is an exponential regression. So you can do that, but if you don't have a calculator, it's just as easy to say, okay, what is 156 divided by 175? What's 142 divided by 156? You'll get a general idea of what the rate is. And it's a rate of decay, so it's going to be a decimal, a fraction. What the rate is just by doing that. So either way, but I want you to pause your video and go ahead and finish number 14. Okay, so if you use stat edit or if you just did division to see what the multiplication factor was, you will come up with 175 with a factor of either 0.89 or 0.9, depending on how you did your rounding. Then at 10 minutes, if we followed this exactly, it would say that our cup of coffee is approximately 54.5 degrees. I would have to ask you, is that reasonable? If that cup of coffee is just sitting on a table in a normal temperature room, it does not seem reasonable that it's going to cool down to 54 degrees. The room's probably around 70. The coffee's not going to cool down below that. So you always need to ask yourself once you get an answer, is this reasonable? And the answer to this would be no. At some point, this is going to hit room temperature, and it's not going to keep getting colder unless we refrigerate it.